Hello, Algebra 2 Part 1. This is the first day of 661, so we'll be in this for 2 days. In this section, what we're doing is we're solving literal equations. So this has some relevance to things that you might be doing in chemistry and then later in physics. And so what this means is we're isolating one variable in an equation. And with the equations that we're going to be working with, we'll have more than one or two or sometimes even three variables. You can see with some of the examples I have down below, right here, s equals vt minus 16t squared. That only has one number in it. And then this formula right here, this is the Pythagorean theorem from geometry. C squared is a squared plus b squared. That doesn't have any number in it at all. So we'll be working with things like that and isolating one variable in them. So obviously, because we have more than one variable in these things that we'll be working with today, when we go ahead and isolate the variable that we're looking for, our answer will not be a single number. It will have other variables in it. So the steps to doing these, what I recommend doing is circle the variable that you want to solve for, and then you're going to be using your addition, multiplication, and distributive properties to get that variable by itself. So it's kind of like solving an equation, doing PEMDAS backwards. And then this last step, plug in the values that you know to get your answer. We're not going to worry about that so much today because we're not really using these formulas for anything. But what we'll be concentrating on is getting the variable by itself. All right, so we'll run through these examples here. So for the first one, we have C is 5/9 f minus 32, and we want to isolate this for f. And in case you didn't know, this is the formula to convert from Fahrenheit to Celsius temperature. So we want to isolate f. So what I'm going to do, I'll just circle that in red for now. And so if I copy this problem over initially, let's see, C 5/9 f minus 32. Okay, so you can see that f is locked up in those parentheses, and so we want to get it out of those parentheses. So the first thing that we could do to unlock those parentheses is multiply both sides by the reciprocal of 5/9, right? So we'll multiply by 9 over 5. So I'm multiplying both sides by 9 over 5, and so what that's going to do is that's going to cancel that fraction in front. So now on the left side, I now have 9/5 c equals, and then that fraction 5/9 went away, f minus 32. And remember, we want to get f by itself. So then our last step is to just add 32 to both sides. So now I have 9/5 c equals, 9/5 c plus 32 is f. And so that's our answer, and we're all done, right? We had to get f by itself, and that's it. So no really serious number crunching here, just getting one variable by itself. All right, so for example 2, we want to get p by itself. And this one's a little tricky because we have p in more than one place. So we start off with, let's see, and I'm going to try to give myself more room. A is p plus PRT. So the tricky thing about this one is p is in two things at once. The nice thing is that everything that contains p is on one side of the equal sign. So what we could actually do is factor it out as though it were a GCF, okay? So my left side is going to stay the same for right now. And what I'm going to do is I'm going to factor out p from both terms on the right side as though it were a GCF. And actually, I'll just keep doing that in blue. So if I factor p out, I get 1 plus RT, right? I just pulled it out like it was a GCF. Same thing as dividing both terms by p. So now what I could do is I could divide both sides by 1 plus RT, right? So I divide this side by 1 plus RT, and then I'll also divide the left by 1 plus RT. And so then what happens is that cancels, and now I'm left with A over 1 plus RT equals P. And I wanted to get p by itself, and I've got it, so I'm all done. All right, let's go on to example 3. So we start off with s over s minus c equals r, and I'm going to write that r over 1, okay? So what we have here, we want to get c by itself, and c is locked up in the denominator of on the left side. And one way that we could get that by itself is we could cross multiply on both sides, and then, you know, when we cross multiply an equation with fractions, we get rid of when we cross multiply, we get rid of our denominators, and we just have one equation to solve. So I'm going to do that. And so if I cross multiply, let's see, I'll have s equals r times s minus c. And remember, we're trying to get c by itself. Okay, so now it's stuck in those parentheses, so we want to get it out of those parentheses, so we could divide both sides by r. Actually, I'll do this in green to make it clear what I'm doing. So we're going to divide both sides by r. So now I have s over r, and I can cancel it on that side, equals, whoops, I'm going all over with my colors here, equals s minus c. And remember, we want to get c by itself, okay? So now what I could do is I could subtract s from both sides. So I will minus s. So now on the left, I have s over r minus s equals a negative c. So I have a negative c. I'd really like a positive c. So then what I could do is I could multiply both sides by a negative 1. Right? Okay, so that'll flip all of my signs. So I'll kick that up here. And if I multiply both sides by a negative 1, so then I have negative s over r plus s, right? Because I just took this negative 1 and distributed it, equals a positive c. And you could leave your answer like this. That's perfectly fine. I would give you full credit for that. Or if you like to have your positive s first, you could do that. And that would give you s minus s over r equals a positive c. And that's your answer. And you're all done. Now what the textbook might do is they might put that all over one denominator. And so they might multiply that big S right here by an R and say that this is SR over R minus S over R equals C. And then they would just throw that over one R. So then they would have SR minus S over R equals C. So this is the kind of answer you might get from the textbook. It's the same thing. They just put everything on the left side over one denominator. All right, so for example 4, let's copy that over. We have t, and actually I'll do the same thing that I did for the last problem. I'll throw that t over 1. So I have t over 1 equals r over r plus 1. And so we want to solve this for r. Okay, so r is locked up there. So what we'll start by doing to get rid of these denominators is we'll cross multiply again. That's always just a really good way to get rid of denominators and fractions. So if I cross multiply, I have t times r plus 1 equals r. Well, we got rid of our denominators, which is really nice. But now the tricky thing is r is on two sides of the equation. So what we want to do, ultimately, is we want to have everything with r on one side of the equation. And the other problem is that r is locked up in a set of parentheses. So one of the first things that we could do is get it out of those parentheses. So what we'll do here is we'll go ahead to get rid of the parentheses first, is we'll distribute this t. And so that'll give us tr plus t equals r. Okay, so no parentheses, that's good. So r is still on two different sides of the equal sign. We want to get it on one side, so what I could do is I could just move this TR over. So if I subtract TR from both sides, move it to the other side, that leaves me with T equals R minus TR. And so now I have an equation where I have R. Every term that contains R is on one side of the equal sign, which is good. And I could do what I did in a previous example, is I could factor R out as though it were a GCF. So if I factor it out as a GCF, right, that means I divide both terms on the right side by R. That'll give me 1 minus T, right? And I still have a T on the left side. Okay, so remember, I want to get R by itself. So I'm going to now divide both sides by 1 minus T. And so that will cancel it on the right side. So now on the left side, I have T over 1 minus T, and that equals my lonely R. And so that's it. That's all we had to do, because we have to get R by itself, and we're all done. So I think those are all the examples I have for you today. So you can go ahead and try the homework on your own. And we'll do this again. We'll practice again with this next class tomorrow.